It's recording. Give me 2 more seconds. All right. Any questions anybody would like me to go over here or afar? 2B. Yes, sir. I could have talked about that in the lesson because we had a fair amount of people asking about that yesterday in class. Anybody at home there, you got questions?
Number 11.
Yep, we got that.
11 was one with the textbook.
Are you okay, Maya? I don't know what that sound was.
Oh, I didn't realize I wasn't on mute. Sorry, that was just zipping around.
Cool. As long as you're okay. Okay, I'm just trying to find the page. Yeah, number 11. Let's kind of put that one to bed. I've screwed that one up so many times. I think I've given a different answer to so many people, so we'll definitely deal with that. Okay, so 2B, we'll start with that. I'm recording. Yep. All my favorite colors. Oh, that's not what I want. All right. 2B says, oh, there's Gavin, unless somebody just left. No, it's Gavin. All right, it says find 8PR, okay. 8PR equals 336. Now, this one is kind of a guess and check. No, but it's not a random guess and check. It's a methodical guess and check. So it's 8 factorial over 8 minus R factorial equals 336. Because and when you say guess check, well, I don't want to just go 1, 2, 3, 4. You don't have to do it that way. Think of it this way: 8 equals 8. Forgive that obviousness. 8 times 7 equals 56. 8 times 7 times 6 equals 336, which means we're looking at the top here. We need 8 times 7 times 6, and that we need that to be all that's left, which means under here, it has to be 5 factorial to cancel. So that means it has to be 8 minus 3 factorial, because this equals 5. So this is like 8 times 7 times 6 times 5 factorial all over 5 factorial. 5's cancel. 8 times 7 times 6 equals 336. Does that make sense? Anybody else? Okay, 11. Question 11 that has tormented me and some of you, because I've screwed it up so many times. Question 11. A company sent out a questionnaire with 8 questions on it. Each question is ranked out of 5. It's 8P5, which means 8 factorial. Is this the exact same question? No, it was 8 minus 3. Over 8 minus 5 factorial, which is 8 factorial over 3 factorial, which is 8 times 7 times 6 times 5 times 4 times 3 factorial over 3 factorial. Cha-ching. Calculator, 20 times 6 is 120. 56 times 120. I don't know that one. 56 times 120. Now, did anyone see anything wrong with anything I did there? Because I know I've done this. I think like I've shown you a different answer. I think I've shown you a different answer. And it's like, so I apologize profusely. Yes, the answer in the back is wrong, but this is right, right?
Oh, good. Good. Okay, that's the one I got. It just was not right in the back. So
Like I think I started by trying to do it in my head, and in my head I did, because I knew it was going to be 3. So I did 8 minus 3 in my head, which is a different answer. I think with Karina, I did combinations, which it's like, anyways. So are we good with that? Sorry, you guys, I apologize. Everybody's good? So we're good with the lesson now? Cool. Yeah, my guess is it has to kind of do with recopying.
Also, the ways people fail sometimes is quite impressive.
Yeah, that's true too. Well, I got an example. Okay, combinations. This feels wrong. There we go. This, it looks a bit weird. These are kind of fractions. This is n factorial over r factorial, n minus r factorial. Same thing here, npr over r factorial. I'll give you a couple seconds to write that down with a handful that haven't asked for it ahead of time. Well, you guys, I had the best wipeout today. I drove because I needed my car today. And it was cold. At least it was when I got here at like 6:30. And so I'm running from my car and like my bare hands, I didn't put mitts on. I'm like they're freezing like right away. And I have my keys in my hand and I'm running. And I get to right by the door at the back door and just cartoon wipeout, like both feet go. And I remember my left leg kind of just twisted under me. And I remember thinking for a second, like, did I injure myself? And it's like, no, it's fine. But as I'm running, my keys in my right hand swings. And so I've got like the rainbow here. So they go up and I'm on my back and I'm watching them climb in the sky and then fall in like Mrs. What's her name? Mrs. Hayes, Mrs. Hayes's parking spot, which is like the handicap parking spot. Like it took so long for the keys to come back down. I was like, so, and I'm boom, I'm on my back and I'm just watching. And so it was funny because then Mario was coming in right after me, Mr. Buenobra. Like I saw his car coming as I was running to the door. And so after I said, do you see me wipe out? And he's like, no. And because he's such a nice guy, that was his only concern. He didn't care about the keys. He was like, are you okay? And I think he probably felt like responsible, even though it like freezing rain overnight. It's like, it's a funny story. You can laugh. He's the best, man. He's the best. Combinations are different from permutations in that order does not matter, which is why you're kind of dividing by more things here. A combination on your lock should really be called a permutation lock. I think I mentioned that yesterday. So you have these formulas, or this formula will be on your test. You should know what this means because I know on like provincial exams, sometimes it'll just like put like 5 and 2 here and and it'll be solved or something. It's like, well, what do I do? So you got to remember that this is for combinations, NCR. No, it's this right here. It's n factorial over r factorial times n minus r factorial. It's just, this is for combinations, excuse me. Does that make sense? Yeah. Anybody still writing notes for this page? Gavin? Okay. I don't know if it's muting. Like you guys aren't seeing anything but my name up here, right? Yeah. Okay. All right. Everybody hates me. Okay. Examples. Oops. Oh, look at, oh, settle down, settle down, settle down. Okay, I'll give you a few moments. That weird bracketed one I'm talking about there was what I was just talking about, like n over, kind of above r. It's not even over r. There's lots of questions. I think we're going to jump to 288, 286, 287. If you want to do those examples, look through them. You totally can, but we're just going to look at the 4 examples on page 288. Can you walk quieter, please?
argue if somebody said like something under something, saying the denominator before the numerator and then saying under?
Like reverse order?
Yeah.
Yes. All right, anybody still writing? I don't even think Gavin's here.
Nope.
Thank you. All right. So we're going to look at page 288. We're going to look at the examples on page 288. Seriously, I need to check. Is Gavin here? Oh, he's not. There you go. What was when Sam came? Oh, yeah. There needs to be 5 people. I'm the 5th participant. Okay. All right. So my first time using this. Give me a minute. All right. Is that clear? It looks kind of funny to me. Funny / fuzzy. Page 288 says, in a hockey league with 9 teams. Anybody seen Ferris Bueller's Day Off? When the principal's on the phone with Ferris's mother, he's been absent 9 times. She's like, 9 times? 9 times. And then on the computer it goes 8, 7, and it goes down to 2, and it's like, boop, saved on super old school computer. 9 times. Hockey league with 9 teams. Each team plays each other exactly once. How many games are there in the season? This is like a 9 choose 2 scenario because it's 2 at a time. And that's kind of the trickiest part of this one. So it's 9 choose 2, which is 9 factorial over 2 factorial times 9 minus 2 factorial. As much as possible. I like to not use a calculator if I don't have to. I probably will here. 4 times 3 times, 2 factorial. I wonder what the answer to 2 factorial is. So it's 2 factorial, and then it's 7 factorial because it's 9 minus 2. So why did I go all the way down to 2? I don't know. 9 times 8 times 7 factorial. There we go. 2 times 7 factorial. 2 factorial, sometimes if I'm going quick, I might do it and I don't want to confuse anybody. I might just write 2 because 2 factorial is 2. Yeah, I see, even Calvin could do it in his head. So we, yeah. So, but here 8 divided by 2 is 4. 9 times 4, 36. There are 36 games. I don't know where to move this little thing. It might be blocking people's view. It doesn't stay. Oh, it does stay to the screen. Yeah, but then if I lose it forever, I won't know how to fix it. Okay, are we good with number 1?
Yeah.
2. How many 5 card? Oh, you guys.
Yeah.
Did I email it to myself? I saw this TikTok video yesterday. Are you familiar with the, anyways, about the different numbers of permutations in a deck of cards? I think I emailed it to myself. Yeah, I'm going to show it to you guys if I can find it. How many 5 card poker hands are possible with 52 card deck? So that's 52C5. This is where a calculator comes in handy. So we have 52 factorial over 5 factorial times 52 minus 5 factorial, which equals 52 times 51 times 50 times 49 times 48 times 47 factorial. 5 factorial times 47 factorial. Now, it's a good idea because you might be thinking, okay, it's so big, I'm just going to put this into the calculator. Some calculators may not give you an answer because it is so big. Granted, everybody's got a scientific calculator with scientific notation, probably will, but I'm just curious. 52 factorial. Okay, it does. But even then, so like that's a crazy number. That's 8.06 times 10 to the 67. If you do that and then you divide by like the 47 factorial, then you're punching in all the scientific notation and all that. You're going to round because you're probably not going to punch in 8.07 blah, blah, blah. So simplify it as much as possible. So we have 52 times, the 47s cancel. I'm going to simplify that a bit. 52 times 51 times 50 times 49 times 48 over 5 times 4 times 3 times 2 times 1. Okay, So it might take a little bit of creativity here, but 2, 6, 6 times 4 is 24. I'm trying to figure out how to do a big number. I'll just do small ones to show you. 5 goes into 50 10 times. 4, yeah, goes into 48 or 52. Doesn't matter which. Let's say 52. 4 goes into 52 10, 13 times. 3 goes into 51 17 times. I don't know. As I'm doing this, you might think, you know what? I think I'll do scientific notation. So, yeah, tricky. So now it's 13 times 17 times 10 times 49 times 24. Much more manageable. 13 times, somebody please remind me to find that TikTok video. Times, thanks. Oof. Now I remember. 49, oops, times 10 times. I ran into this problem yesterday, talking while I was trying to do math. And I ended up writing weird things. So 2,598,960. This is combinations. This is where order doesn't matter. If we were doing this with permutations, it would be lots and lots bigger. Now, while you have a look at number 3, I'm just going to see, because I'm pretty sure I emailed myself that video. I don't want to, instead of kind of digging into my email in front of you guys. Well, that's a bummer. Oh, I'll just find it on TikTok. Okay, number 3, compute. So it's given you this, so you will need to know what this means. The good news is you get something like this, it's always kind of it's always the bigger number first. So it's like, oh, I don't remember. But if it gives you 7 over r, even then you should figure it out. Or n over 3, you know, it's the n first. So anyways, do remember this. So it's 7c3, which is 7 factorial over 3 factorial, 7 minus 3 factorial, which is, so it's going to be a 4. 7 times 6 times 5 times 4 factorial over 3 times 2 times 4 factorial. 3 factorial is 3 times 2. I didn't put the 1 in, right? I'm not going too fast, am I? 4 cancels with 4. 6 cancels with 6. 7 times 5. Calvin's got it. 35. Cool. Whoop. Number 4. We're doing so much of 7, 6, 5. I saw 3 and I thought we had to go to 2 next, and I was confused because 2 was done there. Solve. Do I have enough room? I'm not going to take a chance. If I'm going too fast, or you need me to slow down. Did you listen to it? Isn't it great?
Yeah.
Right, Luke?
Like it was good.
It was very good. You have to move while listening to it.
Yeah. My favorite blues band for sure.
Yeah? Wicked.
Thank you.
You're welcome. I was talking. Yeah, the Black Pumas. I was talking to Mrs. S. I don't know how to say it. The hard part I can say. Is it Grosselak? Does anybody know? I would call her Super Stickman Golf because it's SG. So anyways, I was talking about this music I just discovered. Those of you in my SLG were listening to some of that yesterday. Psychedelic funk. Colors by the Black Pumas. Try and listen to that and just sit still. Goodness gracious. Okay, let's do some work here. Can we focus? Emma, is that okay with you? If we do some math for a change? Good. All right. N factorial. You're sitting there thinking, do I unmute for this? Over 2 factorial times n minus 2 factorial. See where we're going here? Well, you will. Equals n minus 1. Again, stop me if I'm going too fast. I feel like this is going to get in the way now. So I need to cancel this n minus 2. So on the top, I'm going to say n times n minus 1 times n minus 2 factorial. 2 factorial n minus 2 factorial equals n minus 1. Now here's a cool thing. Watch this. So we cancel these. Cha-ching. We can also cancel these n minus 1s. I'm showing you the shortcut. because really the next step mathematically, I'll show you. You don't need to do this next step I'm doing, but I'll show you how it works.
By n minus one
Exactly.
plus
N times n minus 1 over 2, because that's 2 factorial, equals n minus 1. If I divide both sides by n minus 1 or multiply both sides by 1 over n minus 1, because this is over 1, cancels, cancels. And we have n over 2 equals 1. N equals 2. Can you dig it?
So you don't need us to show that extra step if
Nope.
you don't want to?
No, just cancel.
All right.
Just cancel. Now, if you want to substitute it in, maybe I'll use a different color. Let's see that shot. Layup. If you wanted to check it out, check your work. Let's put in 2. So 2 factorial over 2 factorial. 2 minus 2 factorial equals 2 minus 1. Does that work? Well, these cancel. So now I've got 1 over 0 factorial. Did we ever talk about this? 0 factorial equals 1? Okay, so just know that. There's a cool explanation for it, and I don't remember it, but you can find it on YouTube if you want.
Yeah.
So this is 1. So this is 1 over 1 equals 1.
I think it has something.
Quieter. Not you, Calvin.
Does it have something to do with if you're repeating decimals?
I don't remember.
It was very interesting.
It is. It's cool. Those are the examples. Are there any questions? Nobody? Okay, do you guys want to see the TikTok video? How do I do this? My daughter's
Wait,
on.
I have a question.
Yes.
When you say the order doesn't matter, do you actually mean the order doesn't matter? Like if I, for example, question 2, 52C5, if I did 5C52, that'd be the same thing?
That's a good question, because no, that would not work. When it's talking about order doesn't matter, it's talking about the things that you are, it's talking about the things that you're talking about. If I'm talking about cards, a permutation would be 5, 4, 3, 2, 1. That's one possible combination of 5 cards, 1 to 5. Another possible combination is 4, 3, 5, 1, 2, blah, 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 blah. A combination doesn't matter. If you have those 5 cards, that's 1. Does that make sense?
Yeah.
Cool.
Thank you.
Welcome.
Which means if you'd have whatever combination, whatever, and then the same number, like if n and r are equal in combinations, it's just 1.
Yes. You guys, I don't know where this thing is. Yes, got it. Here we go.
Lives in your head rent free. What insane.
Hang on. If you want to go, you can. Don't feel like you need to stay. But I just think this is neat. As long as you can kind of hear it. It's a little blurry, but you can hear it.
What insane stat lives in your head rent free?
What shake and bacon? I've been waiting for this one. Did you know that when you shuffle a deck of cards, you are most likely holding a combination of cards that has never existed before and probably.
When she said that, I was like, no, that's stupid. You shuffle the deck of cards in your hands at one moment. That combination, that permutation has never existed before. Why? Because watch.
Will never exist again. Here's why. There are 52 cards in a standard deck, so all possible combinations will be a factorial of 52. So 52 is multiplied by 51, 50, 49, all the way down to 1. Do you have any idea how big that number is? It's this big. Think of it this way. If you were to shuffle a new combination every nanosecond, which is 1 billionth of 1 second, it would take you this many years to get every possible permutation.
Those aren't decimals. They might look like decimals. Those are commas. That many years, if you did a different order every billionth of a second.
What insane stat?
So anyways, there you go. Math is everywhere, even on TikTok. Any other questions, my friends? I'm really curious to see who's there. Oh, and everybody stayed. Okay, that's all for me. I'm gonna end the meeting. See yas.